Hello and welcome to the webinar, Continuous Integration Must-Haves, How to Guarantee Code Security in Cloud Environments. My name is Eric Wallace with Argyle, and it's great to have everyone joining us today. I have a few administrative details to share with you, and then I'll turn things over to our esteemed panel. First, I'd like to thank Harness for their partnership with today's event. They've been wonderful partners to Argyle, and they're committed to providing you with valuable content and a great overall experience. Thank you again to Harness. We appreciate you joining us today. We also welcome you to stay socially connected during today's event. For those of you who are active on social media, please use the hashtag ArgyleDigital and follow us at Argyle Exec Forum. Also, please be sure to follow Argyle on LinkedIn for special announcements. I also wanted to take a moment to touch on our content neutrality policy, which we've curated based on the feedback we've received over the years from our members. We've worked closely with our speaking faculty to ensure that you receive a set of balanced and neutral viewpoints during the session today, and we appreciate our members' support of this policy. Finally, and most importantly, we want to hear from you, so please submit all questions that come up during today's event into the chat section of the interface. Following the discussion, we've set aside time for our speakers to weigh in on your questions. Now, without further delay, we'll have our speakers introduce themselves, and then we'll begin our presentation. Pranav, over to you.
Hello, everybody. Looking forward to this content on how do we secure builds in the cloud, and I'm pleased to welcome my colleagues who've been working in the security space for an extremely long time. So Andrew, why don't you introduce yourself first, and Luke followed by you second.
Sure, thanks Pranav. Hey everybody, my name is Andrew. I currently am the head of security at Harness. Previously worked across a bunch of different industries, everything from manufacturing to consulting to the electric utilities industry, and for the last 8 or 9 years in the B2B SaaS space. Most recently helped build out the security team at Datadog, and excited to be at Harness. Luke, over to you.
Hey everybody, I'm Luke Hertert. I lead our sales engineering team at Harness for much of the Eastern US. And I've been, across my career, I was a software engineer, I was a CTO of a couple startups. I've worked at a Fortune 50 bank, and I have most recently worked at an observability company called AppDynamics.
And all three of us sort of have been working with lots of customers and in our previous incarnations of before Harness. And what sort of we wanted to share with all of you was some of the learnings that we have seen on how should you think about security when it comes to targeting developers. Like, what do they care about? Like, how do you balance out the two worlds of securing and providing good enough guardrails that you can deploy into production? And we'll talk about some of the key compliance and certification requirements that customers need to think about when they think about CI. Like often enough, like one of the learnings I had is like when people think about CI, it's a lot about connectors, but we'll cover some interesting learnings on other aspects to think about when certifying a CI platform. And then we'll have demos in the end, and hopefully the demo gods will be with us, and we'll be able to show you some interesting aspects of securing builds in a cloud environment. To start it off, it's an interesting philosophy on where does security begin with? Like, does it begin with developers, or does it begin with your CISOs, or does it begin with your InfoSec? And where do the responsibilities of security lie in? Does it lie in with business, or does it lie in with engineering? And like one aspects that we have seen is, we can build a lot of security controls in place, but we also don't want to restrict developers early on so that they can, keep on experimenting with what the code that they're trying to build essentially. And there's always a healthy balance that we have to strike between business and engineering, where business wants to drive results faster, and then engineering wants to deliver a high quality product. But both of these have to come together because the eventual solution has to be secure. Like, you don't want to release something that is insecure day one, and oh my God, the secrets got leaked through various mechanisms. Andrew, what have you seen in practice in terms of striking this balance between business and engineering?
I think that's a great point that you brought up, Pranav, that there are many different stakeholders for security, and that, you know, ultimately security at the business is a shared responsibility. I think when I've had the opportunity to contribute to a security program, or in several instances build out a security program from scratch, there are a couple of things that come to mind for me. I think first is I want to understand and establish some context. Part of that for me is to get to the bottom of what's driving the security investment. This will look different from company to company, and even sometimes from department to department within a company, but understanding why are we doing this is a good place to start. And then I think from there, I really want to organize the go forward plan into strategy and tactical considerations. So that first piece, understanding who the stakeholders are, how are technical and business decisions made, who actually makes those calls, is a useful place to start. Understand who your audience is. And then digging into thinking about our software delivery process. What's the current state and some of the known pain points of the SDLC? I think about, there's a sort of a thought construct called Chesterton's fence that says, never destroy a fence, change a rule, or do away with a tradition until you understand why it's there in the first place. And I think that really applies particularly to security controls and different programs that we want to put in place. We want to know, why is the business doing this? Why are engineers delivering software in a particular way, so that we can better tailor our security, our shared security responsibility throughout that process. So understanding why those fit and who is responsible is a really big place to start. From there, I think another top of mind item for me is building consensus. This isn't a one-man show. This isn't a one-team show. Information security, like we talked about, is a shared responsibility. And so building consensus and agreement with our colleagues around the business is particularly important. I want to understand what are some of the common goals and investments that we share with the technical teams. An example of these could be product SLAs, whether uptime or availability, maybe vulnerability remediation, software quality, our overall platform hygiene, maybe even revenue targets. How can security, both as a function in the business as well as a culture across the organization, help enable the business to move forward? I think another thing to build consensus around is risk management. Coming in as a security leader, as a security practitioner, I really want to partner with my colleagues in engineering, both at the leadership and at the subject matter expert level, to de-risk our software delivery process, and through that de-risking, preserve the velocity of innovation and change. I recently read an article by the CISO of LinkedIn, where he talked about security as a discipline at a company being more akin to social workers and not police officers. I liked that analogy because I think oftentimes security can be seen as a barrier, or as something or someone who is saying no. But really, I want to be at the point where I can say yes, and here's the right way to do it, or here's the secure way to do it. Another item that I look to build consensus around is business continuity. I want to preserve the value that's created by developers, preserve the value that's been built up by the business, whether that's reliability of the platform and of the service, whether that's thinking forward to security incident or breach mitigation, making sure that we have adequate layered controls in place to preserve that value, and then to build on a foundation of customer trust. So when I'm building out a security program, these are the things that I think about in terms of building consensus. Once I've got some consensus around the mission, I also want to understand what some of the existing commitments or drivers might be. So we know what the current state is. What is the target state? I think in many instances, you'll see things like regulatory or customer commitments be an impetus for change, especially with regard to adding more security into the process. See things like internal quality goals, whether again that's software hygiene or building out additional SLAs for specific product lines. These are all things that security can complement and help accelerate. And then finally, I think we want to measure the maturity. So we know what our current state is, we know where our target state is. We want to be able to demonstrate progress as we implement different technologies and make changes to the SDLC, understanding how we measure those things, whether it's some internal metrics or referencing against industry standards from organizations like OWASP or Synopsys or SLSA, which I know we'll talk about a little bit later. So that's on the business side. Over on the engineering side, that's where we start to think a little more tactically. So we want to think about specific technical controls that we can begin to implement. The idea here is that we'd start out with low friction guardrails. Again, we don't want to make changes to processes or technologies that may be critical to that SDLC component. We want to make sure that we understand the context. And so looking for these low friction ways to begin to implement security as a culture, as a discipline across the organization. One of the things that stands out to me is that if you look at different industry studies, whether they're the data breach and incident reports from different vendors or broad surveys across developers in our industry, what you see is that a majority of security toil and security incidents come from a miss of fundamentals. So really starting out, my focus wants to be on these foundational principles and then increasing in sophistication over time. I think one of the ways that we can do that is by establishing a strong security culture that includes training and awareness specific to developers in their context, applicable to their technologies. And I really think that bringing visibility to security and to the paved road, the easy path towards security is a great way to contribute to the overall developer experience. I'm curious, Pranav and Luke, developer experience is one of the things we talk a lot about at Harness. We think about a lot as an organization. What are some of the learnings from the field that you've seen with regard to developer experience and security?
Yeah, I would say that especially when I'm working with our customers in highly regulated industries, banking, finance, insurance, that there's this kind of tension between trying to accommodate developer self-service or shift left, whatever you want to call it, giving people the freedom to do their job in the way they want to do it, but making sure that they're following all the right guardrails. So really trying to strike a balance between making sure people are following the rules and doing things that you need to do from a security and governance posture standpoint, but then also giving them the flexibility to do the things that they should have the creative freedom to do. That's the real tension and nirvana that I see people trying to get to in the market.
Exactly, like, and usually the SDLC process will be sort of broken down into 3 phases as well, where we'll start to look at the pre-prod phase where a lot of developers are sort of committing code, and then how do you secure the code assets, and then different threat vectors that are possible as well. Like somebody might check in a secret is the most common one, right? And then how do you secure your build infrastructure and pipeline, and then how do you start to generate artifacts and being able to trace authenticity of these artifacts are functions which are very close to developers as they're building and deploying applications more quickly. Like and Andrew, what have you seen as a CISO hat on securing code for developers?
Yeah, I think this is another important topic, Pranav, and to your point and to the earlier slide, I think the practice of security, especially in the context of your software development lifecycle, really has to begin with developers. These three pillars have been useful ways for us to think about software security internal to Harness. These have also been useful constructs for us as we talk with our customers about best practices and how those can be solved using the Harness platform. And so really, when we think about pre-production SDLC, there's a lot of nuance between companies and even between different environments, right? Lots of folks have a test environment, a developer, or a development environment. Maybe you've got QA, multiple tiers before production. And so breaking things out into these three pillars can be useful as you start to take stock of what practices and controls you already have in place, and then maybe some gaps that you focus on in the short term. So back to that piece with beginning with developers, I think starting to think about code securely, we look at what's closest to the developer, whether that's within the source code management system, even directly within their development environment. Things like branch protection, which gives us the ability to extend governance across our repositories. This has a sort of a dual benefit with improving that developer experience by reducing rework and providing safeguards against common errors. But then it also circles back to the business piece where we can keep our external commitments, whether that's around our secure SDLC to our customers or through our compliance obligations in different regulated industries. So things like branch protection can be a great place to start to enforce some baseline controls, requiring PR reviews, maybe restricting who can force push or delete code. And then as you graduate up the chain to more production environments, being able to layer on, additional controls around, signed commits and other settings that are designed to protect the business and developer productivity. Speaking of developers, I think pre-commit hooks are also a great way to provide that real-time or near real-time feedback to developers, whether that's for vulnerability scans, static code analysis. You brought up the great point around secrets detection. Hard-coded secrets can be the bane of not just a security team, but of the developers themselves, kicking off a whole workload. And so leveraging things like Trufflehog or Git leaks as a pre-commit hook can help us preserve code cleanliness and avoids scrambling to rotate credentials once the code is actually merged. Looking into the secure build pillar, this is where we really start to see the value of standardization and automation. So wherever we can programmatically apply unified rules, policies, and expectations, both from an operational and a security perspective, I see it as an opportunity to simultaneously accelerate that operational speed and security. Again, Netflix talks about this some years ago as a paved road. Many different components to that paved road, but the general idea is that we want to make the smoothest, fastest path for developers to take, the most secure path for them to take as well. So using things like templates and standardizing around your build process is a great place to centralize your configuration standards and ensure you get the output that you expect. Lots of tools can fit into here, whether that's static analysis or other vulnerability scans, secret scanning, as we talked about, and then understanding what our dependencies are, whether that's going to be against a list of approved or disallowed third-party libraries or components. Maybe that's providing real-time feedback regarding open source licensing and our ability to stay compliant with those requirements. Lots of value in being able to orchestrate these tools as a part of our build process. And then finally, in the secure deploy pillar, this is where maybe we leverage additional types of scanning. So where static analysis or SAST is examining the source code, dynamic analysis or DAST is more of a black box approach. This is looking for vulnerabilities in the compiled code or in the artifact itself. It really gives us parity for what customers are going to see when they run scans on the applications that they're consuming. The secure deployment phase is also a great place to, again, use templates and standardization and ensure that we've got the proper approval and access controls in place.
Which leads us to the next, interesting topic of which scanner to run. And everybody has their own set of sweet scanners, or, this is my favorite scanner that's going to protect from the vulnerability that has been detected everywhere. But it's just hard, in the complexity of the number of scanners, which are both open source and Andrew just mentioned, right? Some are even just black box as well. And I think it's a big challenge on how do you go about sort of integrating all these scanners into your build pipeline? How do you create the so-called, a lot of companies call it the paved path or the golden path or the golden template that everybody has to follow. And I think often enough what we have seen is as you tend to sort of use more and more scanners, like how do you then gauge the quality of the code that is being checked in just becomes a hard problem. And that's where sort of the lines between business and engineering also start to blur in, because like whose problem is it when the scan results are found? Like, is it an engineering problem or is it a business problem? So Luke, like what have you seen in the field in terms of the scanners being used, and how have customers gone about analyzing the insights that they get from these scanners?
Yeah, so I would say, generally speaking, the majority of, especially our enterprise customers, don't have more than one scanner that they've mandated to use. So there's rarely, a single tool that they've found in their research that meets all their SAST, DAST, container scanning needs, SCA, all the different types of scanning that is required to be done. They generally, from what I've seen, land on at least 2 or 3 tools, if not more, that are required as part of their secure pipeline or software delivery lifecycle. And so those are required to be run. Sometimes they're run late in the game, so they're done, toward too far right. So there's a long feedback loop to the software developers, because these tools are time consuming to run or don't have the processes in place. It does end up having quite a bit of context switching for developers, having to go into different tools because they each have their own UIs and different output formats and things. So trying to, get actionable feedback very quickly in a consumable way. These are the challenges that I've seen. And then just standardization. How do I ensure everybody's running all the tools and has them configured in the way that we've mandated? That just can be a challenge. So it's pretty common for there to be, some friction, I would say, across the majority of the customers I speak to.
Sorry. Is there a solution to it, Luke? Or
Yeah, I hope so.
And then I think often enough when we think about security in a post-production phase, we think a lot about like securing the perimeters of the system. But like some other key things to think about from a security perspective is performance and reliability. Like even though performance and reliability tends to be bundled up maybe with functional testing or integration testing, it is important, like from a security perspective as well, to maybe blend these boundaries a little bit and think about different attack vectors that might be security specific, but performance could also lead to denial of service attacks or other attacks that might make the system sort of unreliable as well. And Andrew, like curious on what you have seen in, from a security practitioner's perspective in this space.
Yeah, I think, Pranav, similar to what you and Luke mentioned about security scanners, there can be a lot of complexity here, especially if you're in a regulated industry and have specific requirements around your SDLC itself. I think most companies understand intuitively that deploying into production is an important thing to get right. Generally speaking, it's also something that in the DevOps world, we want to do quickly and frequently and reliably, to your point. And so I think that really underlines the importance of having these secure standards baked into the tooling that we're using to deploy to production. Pipeline and environment hardening, making sure that we've actually taken the time to go through and understand how these systems are configured, who has access to them, to test them regularly with things like chaos engineering or game days, understanding what our failback strategies look like. And then as you're operating, the classics still apply. Things like monitoring and web application firewalls and your sort of classic infrastructure security stack are still applicable, whether you're on-prem, in the cloud, or a hybrid. And then as you're operating, making sure you're collecting and analyzing and correlating security events through your audit logs. Maybe you have an aggregator like a SIM, and then continuous security testing. We talked about the variety of different scanners that are available, looking again to preserve efficiency by making those scanners a part of our pipelines in an automated fashion, with a high confidence in the output of those scanners, maybe some capability to deduplicate vulnerabilities. Also, manual testing through penetration testing, both internally and externally, is also particularly valuable. So yeah, I think those are some of the things that I've seen around our industry, as well as focuses we've had internal at Harness.
And Luke, what have you seen as common deployment gates or integration points that customers have used?
Yeah, so gates, I mean, and this gets beyond just the security conversation, right? So we see security gates, we see quality gates, we see things like infrastructure, like resiliency testing, quality testing, load testing, things like that. I'd say one common thread is that most of my customers have some sort of change management requirement in place where you must have a change ticket. Ideally, that change ticket would have as much context as possible, such as, hey, we ran these security scans and found X number of vulnerabilities, what have you. And then usually there's some approval process before going to production where somebody has to sign off on that change ticket or whatever that might be. So I don't know from the security side of things if there's any silver bullet, but there's usually, or I shouldn't say silver, any sort of like straight commonality in terms of what everyone is requiring. I'm seeing more and more people trying to move to requiring known critical or high vulnerabilities present in an artifact prior to going to production. But across the board, it's really more about, hey, what are your standards and how do you actually enforce that those standards are happening in an auditable way?
Makes sense. Like, so favorite question, which compliance framework is the best compliance framework to pick? Andrew, do you have a favorite?
That sounds like a good way to start a holy war, Pranav. Back to Luke's good point, though. I think about the variety of requirements and gates that customers and that Harness has implemented as a part of the SDLC. I think your compliance commitments can serve as a starting point to understand what those might be. Luke mentioned critical and high CVEs. I know that some of the customers I've worked with and roles that I've held in the past that do business with the federal government or the financial industry with PCI have those types of requirements. And so being able to implement those gates in your software delivery platform can be a huge benefit to not just the customer, but also to our developers. Again, avoiding that rework by catching these things early. I also think about additional drivers for those gates for capabilities in our pipelines, specifically things like the executive order. I think it's 14028 that came out a few years ago on cybersecurity. This mandates a number of requirements that can be fulfilled or at least partially fulfilled by your software delivery system, software bill of materials. Most recently, just in March, there's now a secure software development attestation that companies must sign if they're going to provide software to the federal government. And I think, not just unlocking the go-to-market strategy for companies doing business with the federal government, but also raising the bar in understanding the overall composition of our software and ensuring the diligence of security throughout that SDLC. So it's hard to pick a favorite, but I think there's a lot of good opportunities out there.
It's like choose your favorite ice cream. Something else that's becoming quite relevant is SLSA, which used to be a preview framework and is now gone 1.0. And essentially what SLSA is trying to guarantee is the authenticity of the artifact, like was not tampered with as it went through the build process. And Luke, why is that important for customers? Like, why is maintaining authenticity of artifact important?
Yeah, sure. I mean, so if we think about it, a lot of times, as I've seen my customers try to standard or give freedom on the continuous integration side of things, so just taking source code to artifact, and then they're kind of standardizing on the continuous delivery side, so taking that artifact out to production. So making sure there's I'll just call it a chain of custody, where I can basically prove that the artifact that I built and scanned and tested is the same one that I promoted across all my environments, that I signed off on in my change management, that is what eventually lands in production, that it was built in a secure environment, and all. So it's really about chain of custody and who built it and where they built it. Really having provenance around all that is very critical from an audit standpoint.
Gold standard.
Yeah, I think that's really true, Pranav. I think to Luke's point about change management and understanding the integrity of our production environments, with the adoption and migration of cloud services, everything from cloud service providers to B2B SaaS, there's, I think, an increased interdependency that we all have on each other to be able to ensure that not only are our environments secure, but the data that we're sharing with each other is also accessed and processed and in an ecosystem that we can have some sort of baseline of trust in. And so frameworks like SLSA, understanding some of these common security risks, and then again, coming back to a consensus on this is our baseline, this is our standard, can really help preserve and build on the trust that we all necessarily need to have with each other. I'm a particular fan of this OWASP top 10 CI/CD security risks. This is something that came out, I think, maybe a year or two ago. If you're not familiar, OWASP is the Open Worldwide Application Security Project. It's a nonprofit that puts out guidance and lists like this to help bring sort of a common understanding and a common taxonomy to most of the common risks or vulnerabilities that we see in different parts of web applications and the process of delivering those web applications. So as you look through these, obviously we won't walk through them, but as you look through each of these risks, you'll start to see again some common themes really around access control and verifying your software providers and ensuring that you've put in proper hygiene for your pipelines, your pre-production environments, your production environments. So again, I think back to that point of really the fundamentals are an important thing to focus on, regardless of the stage that you're in.
And I think it's good to have frameworks of, we have frameworks for like app development, performance, like, and OWASP is a good framework. Mitre is another good framework to refer to, which lays out different attack vectors as well as some specific vectors which only apply, for example, to mobile apps, because the process of building and deploying like a mobile app to an Apple store or Google Play Store is very different to building and deploying a web app or an API app, right? Where you might control the distribution, but for mobile, you don't. And understanding sort of this frame of reference and these frameworks, I think is very helpful for organizations to figure out what their security framework and strategy is going to be. We went through a lot of different aspects to it. Like, Andrew, how would you what key takeaway would you want have our users before we jump onto the demo with Luke?
I think three takeaways for me, Pranav. One is software delivery and CI systems should support, accelerate, and secure your SDLC. We should use business priorities and shared objectives, things like revenue and developer experience, along with engineering, to identify our high-value wins. And then finally, we can leverage industry standards like OWASP and SLSA to strengthen the security of our own build process and to hold our suppliers accountable.
Luke, anything you would like to share?
You know me, I just always want to get to the demo.
All right, let's get on to it then.
All right, let me remember where the button is to click to keep sharing. And I just want to remember, I didn't see any questions come through. If anybody has any questions, I'm happy to, you can type in the chat. They'll get bubbled up here. Otherwise, I'm just going to share my screen. You guys give me a thumbs up or let me know when you're able to see my screen. I got it. Cool. All right, you can see my screen? All right. So this is going to be, I've got my standard, here's Harness. For people that don't know Harness, this isn't going to be that. I really am going to laser focus on specifically, the aspects of Harness that address the topics that we discussed today. So be almost completely focused on continuous integration with a focus on the security aspect side of things. I will touch on a couple areas where this bleeds into the CD stage, like the post artifact creation stage, but for the most part, we're going to stay in the CI world. So what you're seeing here is the Harness UI, specifically an end-to-end pipeline. So this is basically taking source code all the way out to production. In the Harness world, you could have just a standalone stage that just does CI and a standalone pipeline that just does CD. You don't have to have it separated out, but we do view these as two distinct problems that require two distinct solutions, and it's helpful to have a cohesive experience across those two. So from the CI side of things, there's going to be some table stakes that are going to be familiar if you've ever looked at a CI pipeline. We're going to clone the code, we're going to build the code, we're going to test the code, we're going to scan the code, and then we're going to generate an artifact and publish it somewhere. A few things that I will call out is you will notice that we are running multiple security scanning tools. So we've got different SaaS, DAS container scanning tools, a mix of open source and commercial tools. I'm just going to flip over to the editor view real quick. One thing that I think that we view as very important is knowing, making it really easy to integrate these tools into your pipeline. So having out of the box support for, all these different scanners so that people don't actually have to know how to run the CLI in a secure way. So if you go and look in Harness, you'll see, a whole boatload of different scanners. There's a couple of different ways that we can orchestrate these scanners or call these scanners. Some of them, we're actually going to orchestrate the scanner and run it during the pipeline. Other types of scanners are running behind the scenes, either on all the time or on a schedule or on an event-based mechanism. So in that scenario, we would do what we call an ingestion scan, which we're going to pull in the results of a scan at pipeline execution time, but that scan has already happened sometime in the past. Regardless of what type of scan we're doing, what scanners we're doing, I think it's really critical to come in here. If I go and look at one of these, you can configure, all right, how much information do we want about this scanner? And specifically, do we want to fail this pipeline based on whether or not there are any highs or criticals or what have you? Once we've run those scanners, and this is what we talked about, I mentioned earlier that most of my customers have multiple tools. Those tools all have different UIs. Having a single interface to be able to view the output across all the different scan types that I have, to say, all right, I've introduced 4 new vulnerabilities with this branch. 3 of them are high, 1 of them is critical. And then, using generative AI to provide recommendations on how to remediate this vulnerability. So basically giving engineers and developers as quick of a feedback loop about what action they need to take, giving them recommendations about how to actually take that action, giving a remediation workflow where they can come in and give feedback and have a feedback loop with the security team, where they need to say, all right, this is a false positive, or I've got a workaround in place, or what have you. And then that would go into a queue for the security team to actually act upon. So making it really easy to run these scanners, consumable output, remediation workflow, that's one aspect of this. Another aspect is, how do I actually ensure, let's say I've given people the keys to the kingdom to build their own CI pipeline. How do I make sure that they've got my Black Duck scan or Sneak scan or Sonar Cube or OWASP scan or I've got my Seekers check in there. This is where Harness is built in what we call Open Policy Agent, or we don't call it. Open Policy Agent is an open source policy engine that we've built on top of to basically allow you to write policies and rules to say every pipeline must include these certain steps. No pipeline is allowed to contain any sort of arbitrary shell scripts. Whatever your rules are, those rules will get evaluated at pipeline execution time to ensure that whether this is a centrally managed, trusted pipeline, or whether I hired an intern yesterday and he wrote his own pipeline, I can be sure that that pipeline is not allowed to run unless it follows all the rules that we've set centrally. Finally, a couple of things around SBOMs, software bill of materials, and attestation, making it very simple to come in here and to basically sign and attest an image using whatever private and public cryptography you have, generating an SBOM of all the open source dependencies. If you want to see under the hood what this looks like, and I apologize for my dogs going crazy in the background. This can be as simple as you saying, what tool do I want to use? We've included a couple right here. And then what format do I want to publish in? These are a couple standard SBOM formats, industry standard SBOM formats. And then you basically provide your private and public key, and we will generate that SBOM and do an attestation. Similarly, on if I go and find that, I actually don't have the, the attestation happens in this step. What do I do with that though? And this is again in the Harness world. Now we're getting into the deployment side of things. How do I actually enforce, once I've built an artifact, that when I go and try and deploy it, we're following the rules? If you're using something like Kubernetes and you've got your own open policy agent that's set to check images to ensure that they're properly signed and everything, and reject it. You can do this at the Kubernetes level, but you also can do this at the pipeline level for non-Kubernetes types of deployments, including Kubernetes deployments, but also non-Kubernetes deployments. So this is where you can come in and basically you can write your own policy that says, here's an example policy that's denying a whole bunch of open source, libraries and dependencies. So you cannot do a deployment with any artifact that contains log4j version under 2.14.0, for example. It will reject and fail this pipeline. Similarly, it's also going to validate the signature. Also, we can come in here and ensure that this image with this tag is signed appropriately. So having built-in steps to when I go to deploy an artifact to ensure that artifact has been signed appropriately, that it doesn't contain any dependency. So this is where we get into the post-CI stage of things. Just wanted to say, whether you're using Harness or not for CD, we've baked in the information that you can go validate at deploy time. Any Pranav or Spangler, do you have anything to add here?
No, this really highlights the whole, like all the topics that we've been talking together, right? Like how easy is it to bring together these complex topics of which scanners to run, how do you aggregate results across these scanners, how do you generate attestations, and how do you verify whether the provenance was correct and the artifact was not. And you didn't have to do anything except, just drag and drop a few Lego boxes together and you just had a pipeline working. And in fact, we're getting a lot of questions from our users as well, like how do you secure the build pipeline? Hopefully the answer is like just use Harness and it's easy.
Yeah, well, so that is interesting. I will say, one thing that a challenge that I've seen with customers is around there, with a lot of tooling out there today, there's a conflation between source code management, role-based access control, who's allowed. We basically combined SCM, role-based access control, and CI/CD, role-based access control. And so that is one thing, trying to actually say who has the access to, edit a pipeline. So there's two things: who can edit it, and then the policies code is inspecting the contents of that pipeline. So between those two things, having fine-grained role-based access control that basically comes in here and says, all right, I'll just show you, I'm not going to go into detail here, but for example, this is a laundry list of all the different things within Harness where you can say, do people have view, create, edit, access, delete? This can be completely separate from the actual, who has access to the code repository as well. You also have a full audit of what changes have been made where. So if I go in here and see, all right, somebody updated a pipeline, I can see a full YAML diff and see that somebody actually changed the architecture of this, this build step to be from AMD to ARM, for example. So having full-based role-based access control, policies code, and a full audit trail, these are all a handful of ways that you can effectively ensure that the right people have access, that the things that they're doing are operating in a trusted way. And then finally, we've got those deploy time steps to validate that we've signed things appropriately and that it doesn't contain any vulnerabilities or banned dependencies. We got one more thing to touch on, Pranav, if we have time here, around kind of connectors, and does that work?
We have time.
Okay. So lastly, I want to talk about the build environment and how we integrate with things. So if you think about, CI and CD, the pipeline is an orchestrator. It's got to talk to a source code management tool. It's got to talk to an artifact repository. It's got to talk to all of your, security scanning tools, SaaS tools, or hosted tools. If you get into the deployment side, we're communicating with VMs or clusters or cloud providers or what have you. So having a very secure mechanism for your build and deploy infrastructure and how you communicate with things, it becomes critical in securing your pipeline. So first of all, from a Harness perspective, we have several flavors that we support that allows our customers to actually self-host their build infrastructure. So you do your builds on your own VMs or in your own Kubernetes cluster or on your own laptop. That's nice because it's as secure as you've made your your networks, which is hopefully super secure. And it also has access to all the stuff behind your firewall that it makes network connectivity very simple. Where things get a little bit tricky is when you want to leverage the power of cloud hosted build runners. So you want to run your builds on someone else's system. There are some benefits here. There are some great reasons why you would want to do this. First of all, you no longer have to manage a build environment. You don't have, people aren't complaining because your build farm is too slow or over capacity, or somebody forgot to upgrade something, what have you. That gets taken off your plate. There's also speed. You can basically, at least in Harness world, we've hyper optimized the build infrastructure to make builds as fast as possible on bare metal VMs. And then finally, there are, and this is probably more in Spangler's world and in Pranav's world, but when we get into the SLSA v3, there are some requirements around how, if you want to be SLSA 3 compliant, you need to build in a trusted third-party cloud environment such as Harness Cloud. So there are many reasons why you would want to do that. It brings forth some challenges. How do I connect to my local enterprise GitHub or my on-prem Artifactory or what have you? Do I want to open up firewall rules that allow the hosted build infra to reach into my environment? And this is where we've come up with, I think, a pretty unique solution that we call Secure Connect that lets you run basically a proxy inside your network that we call Secure Connect, where whenever a build runs inside our cloud, then it will basically, any network traffic can be directed to go through this proxy, and so it can talk to your on-prem Git SCM providers. It can push an artifact to your on-prem Artifactory without a bunch of firewall exposure. So beyond that, just in general, we've got a really great framework to abstract. I think one of the OWASP recommendations or concerns was around secrets management. So how are we authenticating to things like AWS or GitHub or whatever, so in a secure way? So that might look like I'm using credentials. It might look like I'm using IAM roles. It might use OIDC. There are a whole bunch of different ways to do that. So Harness has abstracted instead of me baking in credentials into my pipeline, we have a framework for defining a connector, a reusable connector, and that can use all of the industry best practices for authentication, where somebody can leverage that connector without having access to any of their credentials. So I think that I'll pause there for questions, but that's really, I think, a security-focused and CI-focused demo of the Harness platform. We definitely do a lot more than just CI and security. That if you can look on our website and see what the platform does. But hopefully, this was helpful and informative.
Very much so. It was a trailblazer. I think it's important, to see OIDC as well being picked up by customers. That's sort of, it becomes, the standard of connecting to any cloud resource. And I think a few of our listeners had a few questions, hopefully, that we've been able to answer around how do you contain code security, how do you build your pipelines. One question was, what's the biggest mistake companies have seen that they make in compliance and certification process during their evals? And Andrew, I'll be curious on, as a CISO, what have you seen work well, not work well, as a company who goes through, evaluation for a vendor, and what sort of things they should look for?
Yeah, so the biggest mistake I've seen folks make with compliance requirements during CI/CD, I think one of the challenges is the mentality shift that it might take for folks in the compliance space or in the even technical operations teams to truly implement reasonable and appropriate automation and guardrails within the CI/CD system. I feel like one of the biggest mistakes is missing out on the opportunities that some of the features Luke mentioned, like OPA, being able to manage our policy as code programmatically, is one of the huge wins that a CI/CD platform can bring from a security perspective. Instead of having to do vulnerability scans and secret scans and all of these different activities, access controls and audit logging, instead of having to do those manually, we can shift those over to be done by the robots. And so I think that's probably the biggest mistake I've seen, is missing out on the opportunity for automation and efficiency when adopting a system like this. Let's see, we've got another question here. We're struggling to maintain code security during our software build process. Do you have any advice for us? I think that could be another great webinar all into itself. I would say from my perspective, because that's such a broad topic, I might look back to some of these frameworks that we talked about, looking at the OWASP top 10 for CI/CD risks. This will really give you some good context around where to start looking for ways to harden your security posture in your code build process. You can look at things like the SLSA framework, that's SLSA. This again provides a lot of very high level as well as detailed guidance on how to harden your build environments and ensure the integrity of your artifact all the way from code to binary. And then finally, I would say to then use those frameworks as a starting point. And then as you go through and begin to apply some of these security techniques, look around and consider what might be appropriate for your organization. Another question.
I just like to chime in there because I watched. I mean, so Harness is a startup. I've been here for 5+ years. I watched us walk a journey of this, and I can say that when I first started here, we were not as great a shape as we are now. I watched Andrew come in and take an organization that was struggling to maintain code security during software build, and what I watched him do quite effectively was, first of all, treat it like a journey, right? Was first of all, put the visibility in place. What vulnerabilities do we have out there right now? What vulnerabilities are people introducing that are new? And so that's starting to give people the insights that they need to start taking action. The first stage of that was to have a plan to tackle our backlog. So we've got X number of 100 vulnerabilities that we're aware of. Let's have an initiative to take those down on a team-by-team basis over the next 3 months or what have you. And then once we got to a place where that backlog was gone or non-existent or manageable, then we were able to start putting proactive policies in place that were now blocking people from introducing new vulnerabilities into production. So I would just say that's what I watched Andrew institute here at Harness was it wasn't coming in with an iron fist from the get-go. It was granting visibility, giving people a manageable process to get to a better and better place, and then instituting automated guardrails in place to keep us in a world-class position from a security posture standpoint. I don't know. Feel free to disagree if any of that was incorrect, Andrew, but that's what I watched you personally do here.
No, thanks for the kind words, Luke. And I think you're right. It really does have to be about iteration and bringing visibility. I think one of the biggest mistakes you can make as a security professional is to run around like your hair's on fire. And so taking that iterative approach where you bring visibility is a great place to start. I know we're coming close to time. I think what Luke mentioned, what we just talked about, answered another question around automation of code security. What are the best parts? I'd say vuln management's a great place to start. I think the last question, what can we do once we've found evidence of tampering in our build infrastructure? Outside of the incident response and forensics process that you may need to start thinking about if that's the case, I would say start considering how you want to approach this problem in the future. Luke mentioned the added security benefits of outsourcing your build infrastructure to a company like Harness. I think there's some real tangible benefits there that would be worth considering.
I think that's where ephemeral build infrastructure is better, because then the attack surface is less, because then the VMs are not around. It's another one to think about if you're running into tampering issues. Wow, these were lots of great learnings that we sort of shared, and hopefully all of you enjoyed the webinar. Eric?
Great. Thank you, panel, for that insightful discussion. This concludes today's webinar, and I want to thank everyone for joining us for this excellent virtual event, and thank you again to our partner, Harness. This webinar will be available on demand for the following week. If you'd like to learn more about Argyle, please join us for a short video. Thank you again, and enjoy the rest of your day.